Thanks for the introduction there. I'm going to talk about how to scale up rollouts of components to Kubernetes clusters based on GitOps. The mandatory slide about me. I'm Thor, and I work at Netic, where we supply a managed Kubernetes offering. Netic has started out as a hosting company. So originally we provided virtual machines and helped customers run applications on top of virtual machines, and now we the space of Kubernetes. Offering to manage Kubernetes clusters, both on premise, of course, since we still have data centers, but also in public cloud. And I think at the moment we're around 100 clusters, and it has been growing rather fast the last year or two. So we have done some work and some thinking in how do we actually scale the rollout of all these components that we manage for our customers. I've been working as a developer and architect for a lot of years, but always kind of ending up in the gap between operations and development. And I've been working with Kubernetes since it was 1.5 or something like that, I think. So that's also some years. For today, I'm going to just briefly recap what GitOps actually is. If some of you is not familiar with GitOps, how many is using GitOps on a daily basis here? Yeah, so probably makes sense to just walk through what GitOps is actually all about, and then also briefly touched upon what is that to running Kubernetes besides deploying your application, because there's more to Kubernetes, and there's more to be managed than just the application that we actually want to provide business value. And then we can move into how can we then use GitOps to actually scale this to multiple clusters, and how to manage that. So what is GitOps actually? Well, I was looking at the WeWorks definition of GitOps. WeWorks are the company that originally coined the notion of GitOps, and they currently, I think they actually had previously another definition of what GitOps was, but this is what you will find at their website currently, and basically it's about using Git as a sort of truth for the desired state of your system, and they also emphasize that it's every part of your system, and then you deploy something that can actually draw upon this desired state and bring your environment into sync with it. So basically, it's about reconciliation, right? So many of you work with Kubernetes already, and inside of Kubernetes we are talking about reconciliation, where we actually push something into the API server, a deployment, a service, an ingress, and controllers inside of Kubernetes tries to get the environment into the state that we actually asked to have. And this is pretty much the same, right? Because now we put our desired state into Git, and we have some kind of reconciliation loop that tries to bring our cluster into the state that we defined in our Git repository. So it's also about reconciliation, like the same notion that we are already using inside of Kubernetes. But having our source of truth inside of Git, we can employ the same techniques as we already use for software deployment, right? So we have pull. If we want to review stuff going out into production, we have an audit log based on the Git commit log, so we could enforce, for instance, signed commits into our Git repository. So a lot of the techniques that are using to control our, well, I think I'm falling out a little bit, will also apply to our changes to the infrastructure and to the deployments now. So why is this different from traditional CI? Well, traditionally we have a CI pipeline that is pretty imperative, right? Where you, in the pipeline, you define the steps that have to happen for you to deploy the container, to build the container, to do the tests. And in this case, instead of being imperative, we actually declare what is the desired state of the system. So already there is a difference. Also, in traditional CI, you would provide credentials to a CI server, right? to be able to push out a new deployment from your CI system to a Kubernetes cluster, you will have to give the CI system credentials for your cluster. And often, if we are talking about deploying infrastructure here and not only applications, these credentials have to be rather powerful to actually push out stuff that are affecting all of your cluster. With GitOps, you turn it around, right? So instead of pushing stuff out to your cluster, the GitOps agent will pull in changes from Git. And also there's a decoupling here. Since the cluster itself pulls in changes, the cluster doesn't have to be up when your CI system is running, right? So the cluster, when the cluster comes up, it will pull in the latest changes from Git. So you have asynchronicity here. And as said before, if you, in a traditional CI setup, you would have to kind of look into the pipelines to see what actually happened and who did what. Here, having the Git log, we have a clear audit trail of who did actually do which changes to our desired state. And we have a single source of truth. Instead of going through, say, one pipeline for each application, we have one place where we can look at what is the complete desired state of our system. We'll see in a moment that we might need to have more than one repository, though. So there might be a little bit more than one single source of truth anyway. But yeah. So that's kind of some of the differences between GitOps and the traditional CI/CD. But what about Kubernetes itself? What is it that we actually going to deploy out there, and why is it interesting to maybe deploy across multiple clusters? Well, we have our application, of course, and the application is where the business logic and the business value is placed. However, a vanilla Kubernetes cluster doesn't contain much other than just the cluster and the capabilities of doing rolling deployments and all that stuff. But you'd have to put other stuff into your cluster before it's actually ready to run your application, right? You probably know that if you're running Kubernetes already. We have to have an ingress controller. We might need something to pick up our metrics. We might want a cert manager to be able to handle certificates. We might want something like external secrets. And now we're talking GitOps, so we also want some kind of GitOps agent. In our case, we're using Flux. Another very popular component for doing that is Argo CD. So all of this is kind of an infrastructure layer that is going across the applications that we deploy in our cluster. And we need to manage all these components, whether you manage those yourself or whether you outsource it to someone else. The component needs to go into Kubernetes because these kind of problems is not solved in the vanilla Kubernetes cluster. So we need to manage this. And coming back to the vWorks definition of GitOps, we probably want to manage these components as well as the application using GitOps. And we want the infrastructure layer to be close to the same across our clusters, right? So if we're running, say, 10 clusters, test, staging, production, and so on, we want the same infrastructure components. We want the same ingress controller to run in our staging environment as we are running in our production environment, so that when we are changing the application, we are testing the application and we are not testing changes to the infrastructure. So we want this source of truth for both the application and the infrastructure. Actually, in our case, the first thing that goes into a Kubernetes cluster when it has been started up, whether it's on-premise or whether it's in some public cloud, is the GitOps agent. And then we can start rolling out all the other stuff here. So, moving into concrete, how this would look if we start out simple here and say we want to apply the GitOps technique to just one cluster, and we want to make it clear what is application and what is infrastructure. Then we could create a Git cluster, right? A Git repository with a very simple directory structure, having one folder for our application and another folder for our infrastructure. Then it's very clear to the guys actually changing stuff that we have applications and we have infrastructure. So we create a single cluster, we create a single repository, and every time we commit something to main in our Git repository, it will go out into the cluster. Then we can apply, of course, as said before, we can apply the techniques that we also use for software development. So the commits on main might be a result of merging a pull request or something else. But basically, every time something is committed to main, one way or another, it will go out into the cluster shortly after that. So before moving on to the more complex example, I just want to introduce the demonstration environment here. So I'm going to show the simple example for a start, and for the sake of demonstration here, I have created a very, very simple Git server. It's basically just a container with an SSH daemon running Git. And then for the demonstration, I'm running kind clusters. Kind is Kubernetes in Docker, and kind is actually the system that the Kubernetes project uses for testing out new Kubernetes releases. So it can run on a laptop and pretty much simulate every aspect of a Kubernetes cluster. And then for the sake of the example, I have a very, very simple application called podinfo, which is kind of a demo microservice written. It's part of the Flux. It's a guy that has created Flux that also have this example deployment microservice. And then for the infrastructure layer, it's just basically an Nginx Ingress controller that's deployed, just to say that, okay, we have something that is infrastructure and we have something that is application. So let's see how this works out in a cluster. Basically, I have some scripts that already bootstrapped Flux into the cluster. So the Flux controllers are running, and what I will deploy to actually get the GitOps reconciliation up and running is a custom resource called Git repository, where I tell Flux, hey, I have a Git repository here that I want you to kind of pull in. And then on top of that, I put a customization resource that points to the Git repository, as you can see here. And there's a path also that says, hey, everything in this Git repository, I basically just want to apply to my cluster. So anything that is coming from main of the Git repository is basically just applied into the cluster. So let's take a look. It should be up and running already. So basically, this is a cluster that is not running very much besides the basic Kubernetes components, right? So there is a namespace called Flux system where the different controllers for Flux is running, and then I have the podinfo application that is deployed in default, and I have the Ingress controller here. And if we take a look at the files, basically, I have here a symbol. Symbol is the root of the Git repository that has been checked out here, and I have the applications where deployment and so on, and I have the infrastructure where there's a YAML file containing basically the Ingress controller. And then by using the Flux CLI for the bootstrap, Flux actually adds itself to the mix also here. So basically, when we have bootstrapped the cluster, we'll also be able to upgrade the GitOps agent itself. So if I was to go in and upgrade Flux to a newer version, I could basically just change the Flux deployment here and then roll out a new version. So once you have bootstrapped it, you can manage also Flux from itself. And then basically the sync file here is the two custom resources that you saw before, right? So there's a Git repository and there's a customization. And we can, of course, find these over here also. We can see that the Git share was checked out here. This is the Git repository, and then I can look at the customization and see that it actually applied all the YAML manifests from this commit share. Some of you might know Customize as a CLI tool that is actually capable of doing simple patching and a simple manipulation of YAML manifests before applying them into a Kubernetes cluster. And Flux is kind of building on top of that. So when you apply manifests from your Git system, it is always done using Customize. Whether you actually want to manipulate them or not, you can just deploy the vanilla YAML files, or you can do a little bit of manipulation before you push them into your cluster. So I'll just tear this down. Yep. So pretty easy, and now I can control this one cluster. But what if I had multiple clusters? And I guess most of you will at least have a development and a production cluster, probably more, because you want to be able to. Of course, with Kubernetes, you could isolate stuff and use namespaces and all that stuff that are part of Kubernetes. But sometimes new versions of Kubernetes also comes out, right? So you might want to test that your applications are running okay on Kubernetes 1.28 when it comes out, right? So you might want to actually have a dev cluster that that you are capable of running your applications on another Kubernetes version than the other components, the other production environments that you are running. So at least 2 clusters, most will probably have at least 2 clusters in the setup. As for us, since we are running clusters for our customers, we are close to 100 clusters now, because customers basically want their own cluster, right? So there are no crossover effects between one customer and another. So we need some way of scaling up this very, very simple setup that we started out having here. We could start out with a very simple approach and saying, hey, we are working with Git. We could create a directory structure that actually reflects which stuff should go into which cluster. So say that instead of just applying everything to the cluster, as we did in the simple example, we could create a tree structure there in our Git repository and say, okay, we create a folder called clusters, and for each cluster, we create a subfolder. So basically now I want to apply stuff from the cluster 1 folder to my cluster 1, and then for stuff for cluster 2 in the cluster 2 folder, basically, right? And then customize allows us to include stuff. So basically I can include the infrastructure folder for both cluster 1 and 2. So anything that goes into the infrastructure folder will be applied to all of my clusters. That would be a simple way of handling multiple clusters. And again, as before, every time I then do a commit on the main branch, it will roll out to whichever clusters are affected by that change, right? For the change in the case that we're using Flux to actually do this for real, it's basically the customization resource that you saw before that we can change and say, hey, okay, now instead of just applying from the root of our Git repository, I want to apply stuff from the folder cluster 001 or from the folder cluster 002 in the second cluster. So let's see how that works out. If it has started, yeah. So we can take a look at now I have 2 clusters running here instead of 1. So I have the cluster 001, as you can see here. And basically it's running the same stuff as before, right? So the pod info is running, the Flux is running, Ingress is running. And if I take a look at cluster 2, it's the same story, just cluster 2 doesn't have the same set of applications. So for cluster 2, actually, we haven't deployed any applications right now. So pod info is not running in cluster 2, but the Ingress controller that is part of the infrastructure is running in cluster 2. And of course, Flux is also running in cluster 2. And if we take a look now at the customization resource, we can see here, if we go into it, that for cluster 2, the path is cluster 002. And if we do the same thing here in cluster 1, we'll see that this is reconciling against another folder. And then if we take a look at the stuff that are then actually here in the folder, we have this customization YAML file, which is kind of configuration for customize. So if I open this I can see that, okay, I have something that is specific for cluster 001, the pod info deployment, and also the basic synchronization. And then I have, I include the stuff from the infrastructure folder. And the infrastructure in this case is the Flux toolkit itself, and then the Ingress controller. And of course, I do the same for cluster 002. So now both clusters are sharing the same infrastructure, basically. So I could go in here and say, okay, well, I have this super awesome new flag. If I could spell it out. Super awesome flag here that I wanted to add to my Ingress controller. So basically, I would just add this in the infrastructure folder, and I could go in and add it to Git, of course. So git add and push. Now, since this simple Git server I have spun up here is actually, I'm manipulating the source files for the Git server here. So sometimes it breaks, but let's see. Let's see if we get through right now. And if we note the git sha here, then shortly Flux should actually update and from C5 to 21 here, right? So if you take a look, it actually updated to 21 now, and we can take a look at the pods in the cluster. And whoops, we actually broke the Ingress controller now because this super awesome flag apparently wasn't part of this. Let's take a look at the other cluster then. Oops. We also broke it in the other cluster. So not very good, right? So what just happened here? So, well, everything was running fine, right? We reconciled against main, and both clusters were picking up changes. But now I introduced a bug here, and this bug actually spread out to both clusters at the same time, because there's kind of nothing to isolate it, right? We are running on the same folder. So so we probably, if we are running 100 clusters or 1,000, we probably need some way of mitigate this, right? So that's in essence what's it about to scale up here, and well, we are running in Git here. One issue is that maybe you could argue that we are actually messing up different life cycles, right? Because you have one life cycle of your cluster, you deploy new stuff to the cluster, maybe you change stuff to your cluster, but you also have kind of the infrastructure where you deploy new stuff to your infrastructure, and that has another life cycle. And right now we are keeping this kind of inside of the same repository, so it's kind of hard to distinguish what is actually a cluster-specific change and what is an infrastructure change. So one thing that we could start out doing is actually split up. Now, then we don't have a single source of truth, but we could split up so that we have our infrastructure stuff and configuration in another Git repository. And having done that, we could start applying some of the versioning techniques that we're using for other stuff, right? Because we are in Git, so we have stuff like tags, which we normally use for versioning of our software. So instead of just rolling out every commit to our cluster, we could tag our infrastructure components. So we could say, hey, now I have the Ingress controller and Flux in version something, and this combination of components we could tag with a 000, for instance, and so on. So every time I change something, I create a new tag we would normally do with our software. And then for each cluster, instead of just applying the head of our Git repository, I could say, okay, at this point in time, I want cluster 1 to run on version 0, cluster 2 to run on version 0, and cluster 3. And then if I want to bump and have my super awesome flag implemented in cluster 1, I could just bump the version of the infrastructure for just cluster 1. Right? So at this point in time, when I do this commit, I just change the version that should be fetched down here. So instead of just fetching from main, I fetch a specific tag. So easy, problem solved, right? Now the rollouts are actually fully versioned, and we are mitigating the risk of rolling out something to a lot of clusters in one go? Well, this is scaling linear with the number of clusters, right? Because every time we put in a new cluster, we also have a configuration that is specific for that cluster to tell which specific tag in our infrastructure is this cluster running on. So every time we get a new cluster, we also get one more tag to maintain. And the more cluster we get, the more different combinations we actually have to run, right? So if we have 100 clusters and we have 100 tags on our infrastructure, we risk that all these 100 clusters are actually running on different tags of the infrastructure. And that also gets kind of hard to manage. So what I'm going to do, we need some more sustainable way of scaling this. We need to be able to roll out to multiple clusters. So we need to, in one way or another, be able to kind of define some groups of clusters that we roll out to. So traditionally, we could apply something like the dev test staging pod approach to the infrastructure also, right? But probably both for you and especially in a company like ours, we just provide managed clusters, right? So what the customers use the cluster for isn't really, of course, often we know it, but it isn't really our concern, right? So if we deliver a cluster to a customer, it's basically a production cluster. We shouldn't mess up the production clusters of our customers by testing out stuff in those, and you probably have it the same way. You don't want your development cluster to be messed up because someone wants to try out a new English controller, right? So this way of handling infrastructure changes in the same way as we do with the applications is probably or might not be the best approach. So what else could we do? Well, we started looking at how technology is adopted in general, because we actually kind of want our customers to be able to have a choice here, because there's also some opportunity in actually getting the new version and the new features a little bit before the remaining here. So you might be a customer that actually wants these new features, wants to take the opportunity there, and then can live with taking a little bit of risk that something might break. It can also be that you have a more resilient application that is actually capable of surviving some bumps on the way. So we actually turned to this theory by a guy that is named Rogers. He made this that's a little bit early. Diffusion of innovation theory, and that's basically it's concerned with how people are taking in new technology. So this is actually the distribution of people and how people are adopting new technology. And some persons are risk prone and want the new features because they see an opportunity and want to test out new stuff. Some early adopters see there's some opportunity here, but we just want it to mature just a little bit, and so on. So basically, it's a trade-off between opportunity and risk, and there is a little bit more detail on how these categories of people is described. So basically, what we have done is that we say, hey, as a customer, you can actually choose where on this cycle do you want your clusters to be. So you may have some clusters where you actually do innovation, and often, for instance, dev clusters where you want to have stuff rather fast, but you also are willing to take the risk of something that might break. Now, it's not like we do not test stuff because before it actually go into innovators, right? We have some platform clusters and some test clusters that are not running any production workloads. But as a customer, the first place that you would get new changes and new features would be in the innovators zone, right? And then you can kind of move up, right? So you can have a cluster that are in the early adopters zone where you say, okay, we have some production workloads here that actually can benefit from having new features rather quickly, and then so on. you can see, for instance, late majority, you might have some critical workloads and you want to make sure that a new component has been running in a number of clusters before it actually hits your clusters. And then you can kind of categorize your cluster as late majority. And this goes for, of course, also some of the infrastructure beneath, right? So rolling out new versions of Kubernetes, of course, we would roll out the version of Kubernetes to innovators first and so on. But how do we actually then implement this using GitOps? Well, instead of working with tags here, we could turn to branches. So we still split up the cluster-specific stuff into some Git repositories that are actually the starting point for bootstrapping a cluster. But then we have the infrastructure repository, and instead of just having main and tagging different releases, we actually create the branches that correspond to the resilience zones that you just saw. So we have an innovators branch where stuff start up. Perhaps it startups a little bit early on, but basically the innovators, and then we have a promotion path down through the branches here. So when it has been running in all the innovators clusters for a while, we merge it down to early adopters and down to early majority, and so on. Then we have created some automation here. So the moment that we actually have a difference between innovators and early adopters, we create the pull requests automatically. We are not approving it, but it's there. So when we have matured the innovator stuff, we can basically merge the pull request, and then the next pull request fires off, because now there is a difference between early adopters and early majority. So there is a little bit of tooling and a little bit of automation beneath this. So let's take a look at the same rollout as we did before here. Just a moment. So basically, the source code for the examples is on GitHub. I think the link there is at the end of the presentation. But basically, there's some scripts that starts up the stuff that you saw before. Now I just forgot to, or I was in the wrong directory, so I didn't delete the old one here. We'll just take a little moment. Let's see. So basically now we can go through. Basically now we have created, instead of having just one repository, we have the clusters in one. This is the root of one Git repository, and this is the root of the other Git repository. And now if we take a look at what's in the cluster, we still have for cluster 001, it deploys the pod info application. And then we got this new infrastructure resources, and basically now we add one more Git repository. So when the cluster is up and running in a moment, we can see that there will be 2 Git repository resources out there. And if we examine the specific URL for the Git repository, we'll see that for this, it's infrastructure instead of clusters. And then basically for the example here, as we saw in the very first example, basically it just applies everything. But the other trick here is that we also pick a branch here other than main. So for this infrastructure repository, we pick the branch innovators. If we take a look at cluster 002, it will pick the branch early adopters. And then let's take a look if we are up and running. We are up and running. This is the root of the infrastructure repository, and basically that's the same contents as was in the folder before. Now it's just moved into its own repository. So Flux itself is there, and the Ingress controller is there. And now we should be up and running. Not sure if all containers, the last container is spinning up here. So the Ingress controller is up, we have Flux, we have pod info just as before. And if we look at the Git repositories here, we can see that now there's 2 Git repositories. One is pointing to the clusters, and one is pointing to the infrastructure. And as you saw before, then clusters is still running on main, but infrastructure is running on the branch that matches the category of the cluster or the zone of the cluster. So if I were to do the same change as before, I still believe that there should be a super awesome flag for Nginx controller here. I could basically do the same thing, right? Because it's the same basic idea. And now we are in infrastructure, and I could say add and commit. If I was changing the right file, I could. This is just for the Git repository. Basically, this is the source for creating the Git repository. So there's no Git here, whereas this is actually the copy where put it here instead. This is actually the copy that is checked out. Oops, that's better. And then in 30 seconds or so, it should try to reconcile the infrastructure. It was probably this 6F, and we can see the commit down here, yeah, 6F. So now, of course, this still crashes, but since we only have it on the innovators and not the early adopters, if we go into the cluster 002, now we should see that cluster 002 is unaffected, right? Because that's still running on the old version of the English controller. We haven't kind of promoted any change here. So it is possible, and GitOps is very, very powerful to do this. We can actually sit in one Git repository and roll out stuff to a number of clusters, but we have to kind of observe the blast zones that we are willing to risk. And if you have a setup with like a fewer clusters, the approach with using Git tags might be okay. But if you need to scale up and you need not to have kind of this linear scale up, then you probably need something else besides the Git tags. We actually started out doing the Git tagging approach instead, but it just become tedious to actually go in and update the infrastructure tag for each cluster individually. It doesn't scale when you get a lot of clusters. So consider what is right in your context, and then, as I said before, we have done some automation around the pull requests and validating whether you're actually changing something that you shouldn't be changing and so on. And we are also doing some stuff around visibility into this promotion path, so that the customers can see which components is actually running in my cluster right now and which are on the way. So when we know that a component has been upgraded in the innovators clusters, then if we have customers that have cluster in late majority, we know that in a few promotions they will be hit by a new version of the English controller, for instance. So we are also building some visualization around this for our customers. Yeah, but yeah, I think that was pretty much what I chosen to take.
Thank you very much. Let's
Thank
give
you.
her a round of applause.